Good. Hello, everybody. This is week 2 of programming. So, we're going to kind of keep to the same kind of approach that we did last week, in that I'm going to introduce some new stuff, and we're going to continue to have Micah's presentations on the specifics of the Python programming language. This week, you'll be looking at things, what we call conditionals and Boolean logic and things like that. In other words, this is how we make decisions in computers. And so I thought it would be important, and what I'm developing out kind of in parallel is expansions to the algorithm process that we've been talking about. And for the first time, the algorithm will be part of your requirements for completing program 2 when you get around to doing that. So let's talk a little bit about. Let's go ahead and go to the slide deck and see where we're going to be in that. So the goal of this lesson is for you guys to be able to extend your understanding of algorithms by extending our example algorithm to include Python features that have been demonstrated either in the previous week, and which I covered in the previous demo on the algorithm, and those features which will be just demonstrated in the current week. So it's going to follow very similar to what we did last time. There's this presentation, and in the presentation and the slide deck, we're going to see how I changed the algorithm to take into account some of the new capabilities we have, in particular conditionals, because I'd already demonstrated last week how you could do things like input, output, and some very very basic programming, assigning values to variables, and assigning values to variables and printing the output and getting the input. So those are kind of the basic things that were in last week. This week we're going to add conditionals. We're going to add in a simple question or two in there to kind of allow the user to guide the direction of the program. So it's not going to be big, and this should be a relatively short thing. But again, thanks to Micah for stepping in and providing these lessons, these continued lessons on conditionals, while I continue to work on expanding out the algorithm part of it. So without further ado, let's make a move over to the presentation. And so we see that the goal of the lesson is for you to I've already done that part of it. The goal of this lesson is for the student to extend their understanding of algorithms by extending our example algorithm to include Python features that have been demonstrated previously and those which will be demonstrated in the current week. Okay. So first of all, let's take a look back at where our algorithm was in the last presentation. I'm not going to read through this, but we just kind of wanted to flash this up here so you had a basic idea where we are. But you see that basically we had 3 major steps, and step 1 had been broken out into 3 sub-steps. I'm going to take a quick, short moment here to do a public service announcement. So most of you didn't have any problems with this, but when you present your algorithms, coming out of now having reviewed everybody's algorithm homework, one of the more consistent comments I had was, number 1, make sure that stepwise refinement is clear in your algorithm, and you can do that in the structure you kind of see here, where you've got one. We started with step 1, and then we went to 2 and 3, and then when I expanded substeps into 1, I labeled 1.a, 1.b, 1.c. Now, some people would start with just simply the step, and then they would put bullets underneath, and that's fine. If you bullet it underneath it, or use, some other kind of methodology to show that, okay, this is actually a part of what was originally step. So originally we had step 1, 2, 3, and then I broke 1 into 1A, 1B, 1C. so we could see this. We could see stepwise refinement in there, and that's really where I want you guys to kind of. Where a few people they just listed out a bunch of steps, which is still an algorithm. But what I really wanted to see was that you had thought it through. The other thing I saw out of the algorithms a lot was things like a lot of times you would call for something that you know, a lot of you, for instance, probably the most common algorithm I got was making a peanut butter jelly sandwich, and that's fine. I had no problems with it. Thought it was kind of funny, but okay. But a lot of times people would say, "Well, okay, get your peanut butter and your bread, and you know, and your jelly," and then they would go on to list the steps beyond that. And somewhere in there, they would say like, "Spread the peanut butter with a knife." Really? What did you say I had to need a knife? You assumed that I had a knife, and that's the kind of things you can't do in algorithms. You can't assume. So most people had a preparation step where they would talk about these are the ingredients you're going to need for this algorithm. That's great. That's perfect. But oftentimes, what would happen is later on in the algorithm, they would make reference to something that they hadn't put in the list of things that were necessary. So, those are the kinds of things that in real life, yeah, someone would figure it out. They'd go get a knife. They probably have a knife, or they'd figure out some kind of substitute, a spoon or their finger or whatever they would use. Okay, that's fine. But, when we're talking computer algorithms, and this is the point I made to several people out there. Yes, we're writing in English, but ultimately our goal is to be able to do these things on a computer. And a computer is not very bright at all. For one thing, it doesn't learn from prior experience. When your program is done, it forgets everything that you had in there. It doesn't have that kind of memory, so to speak. It doesn't build on prior experiences and infer what you want. You have to tell it explicitly what you want. So if you need something, you have to provide it. So you've got to think about how you're going to provide that. And that was one of the more common things that I saw out there that I comment on a lot of times. So anyway, what else was it that I saw? There were some other things that'll pop up as we move along here through the presentation. So, so now that we've looked at this algorithm, now we all know it was an ultra simple algorithm. It was pretty limited, pretty clunky, didn't do an awful lot, but we had very little to work with. And to tell you the truth, we don't have a ton more now. So there's not going to be a lot here today. But when I start thinking about what would a program like this what should it really be able to do? Well, for one thing, the limit of 3 numbers was kind of pretty artificial, and made it kind of a trivial exercise. But again, we're still not at a point where we have the right kind of tools that would allow us to have the user say how many numbers they wanted to average. So I got to thinking about that, and I said, well, what else could this be useful for? Well, there's other versions that people tend to think of as average, but in mathematics are known as the mean and the median and the mode. And I thought, well, people might want to be able to, in addition to getting the average, they might also want to be able to get the mean, median, and mode. And then I got to thinking about, well, what happens with error checking? And much of that we're too early on. But I did actually manage to slide some in. Actually, it's not in the algorithm, but it is in the program. We'll see it in a few minutes. But so at the end of the day, what I came up with was, the other thing too was I started working with mode. And to tell you the truth, when we get there, well, let's go through and find out what mean, median, and mode are first. So anyway, mean is just the mathematical term for average, as most people call it. So the way it was termed in several different things that I was reading up on said average is kind of the informal way of saying mean. So when we're talking about mathematics, we're going to call it mean. So from now on, that's what we're going to refer to. Instead of average, we're going to talk about mean. So the median, however, is if you have a list of numbers, that same list that you might use to develop a mean, also has what's called a median. And essentially, the median is the middle number in the list of numbers. So if you have an even number, if you have an odd number of numbers, that's pretty easy. You figure it out. So in our example so far, we've got three numbers. So it's going to be the second one every time. However, assuming we get to a point, and we will later on, get to a point where we say, okay, how many numbers do you want to average? Then or maybe it would be even more like enter your first number, enter your second number, and each time it's like, are you done? Are you done? Are you done? So in other words, a person could put in an arbitrary number of numbers, but the important thing to understand is that the the median is always going to be the middle number in an odd set of numbers. So in our case, it's going to be the second. If you had 5, it'd be the third. If you had seven, it'd be the fourth number. So on, so on, and so on. But in the event of an even number of numbers, and this is one I had probably forgotten. I probably knew long ago, but have forgotten. I remember median coming up at some point in my studies, and it turns out, unlike the straightforward middle number, it is you take the two middle numbers, because of course on the even you don't have an even number. So if you've got four numbers, it's going to be the second and the third number are going to be the two median numbers, and you take those two numbers and you average them. And I had completely forgotten about that, but that is how you come up with the median. Well, again, we're not going to have to worry too much about that, because in the case of so far where we're at, since we're taking exactly three numbers, it's always going to be odd. And because we're taking the three numbers, exactly three numbers, the median is always going to be the second number. So there's not a lot to do with that here, but it does help us to demonstrate out and work out some things about the conditional statements. So we're going to see a little bit more of that. And so, again, again, as I say here, the current state of our program, it's always going to be the second number, but this is going to change pretty quick. By next week, we'll be doing other things. And then mode is the most frequently occurring number in a list of numbers. So again, we're going to hold off on this. I thought that with 3 we could do it with conditionals, but it got to be ugly quick, and I finally said, let's just not mess with it this time around. There are more straightforward ways to do it than you would do with conditionals. I mean, conditionals still play in there, but there's other techniques that we would typically use to go through a list of numbers and then figure out which number was the highest frequency within that list. So we're going to hold on that. We're going to pass on it for right now, trying not to burn everybody out. So okay, so we're going to basically, what we're going to do is we're going to add in the capability of we're going to change average to mean, and we're going to do the median. And we're going to we're going to ask a few more questions, put a little bit more control in here. And again, it doesn't show in the algorithm, but when we get to the code here in a few minutes, you're going to see where I did it in the code, where I did some error checking in the code, very basic error checking. So anyway, so you'll notice that 1A through 1C don't really change. So we don't have to do anything about that. However, Now, once we've got those three numbers, then we're going to ask if they want the mean or the median. And that means, and I didn't put that in here either because, again, that's where I kind of already knew I needed to do this, but that means I'm going to have to get that result, that choice of theirs, and put it in a variable so that I can do conditionals. I can do a conditional statement with that variable later. So, um, and then so you notice here, step 3, if mean is to be calculated. So now we're beginning to see the first of our conditionals. We're saying if mean is to be calculated, so that result of the ask is going to go in a variable, and then we're going to use that variable within a conditional statement to determine if they want to do the mean. If the answer to that is yes, then what we're going to do is we're going to do the same step that we did previously. Add the first, second, and third numbers and store the result in a variable called s. And from there, we're going to also divide s by 3 and store the result in a variable called a. And then we're going to output, and notice I added a different prompt. Output mean is a. Otherwise, if the median is to calculate it, then output median is whatever this is, the second number. Remember I said that, if we had more than 3 numbers, if we allowed a variable number of numbers, some range of numbers, then we'd have to do some more work, and we're going to do that later on. But at this point, you're not ready for it, and I don't want to start messing with your head before we're ready to go there. So we're just going to but the reality of it is, because we know it's the second number, if someone asks for the median, we're going to give them the second number back. And that's it. So the changes are pretty small in this version of the algorithm, but we've expanded to encompass conditionals, and so within the next few weeks, we're going to have a lot more tools to do more interesting things with this algorithm, and the resulting code out of it as well. So that's it for the slide deck. What I'd like to do now is let's take a look at the code. So you'll notice the code. Let me expand this out so you can see it. You'll notice that the code is largely the same at the beginning. Again, note the comments in here that I've commented frequently. Notice the style at the beginning, all that kind of stuff. There are requirements within one of the things that you'll be graded on in your program, in addition to the algorithm itself. And in the algorithm, I'm going to be looking for presentation is the category I call it, and that's things like showing your stepwise refinement structure. However you do it, I don't really care that you do it, but whatever you do, the other thing you need to do is make sure you do it consistently. So if you're going to do a 1.a and a 1.b and a 1.c, and then one space and then your letters, that's fine. Just make sure everything lines up, same spaces are there. If you're going to do bullets, that's great, but make sure everything's spaced out nice. Does it really matter for the computer? No, it really doesn't. But it does matter as you go into the professional world, because if people see your work as sloppy, they're going to question whether all your work is sloppy. So you need to be professional in your communications, just as professional in your communications as you are in your code, because it does reflect on your work. And if you're looking to get ahead in life, you want to make sure that you don't look like an idiot when you're writing stuff. So believe it or not, I've spent the last nearly 30 years in the civilian professional world, and there's plenty of people that can't write worth a darn. And you know what? They're never going to get to the top jobs. Just the way it works, right? All things being considered, the ability to communicate well, clearly, is very highly desired. And if you don't have those capabilities, then you're not gonna you're not gonna do as well as you might want to. Now, if all you want to do is sling code your whole career, that's fine. Don't worry about it, you know. But if you're looking at some point of moving up and and doing different things and having greater opportunities, then you need to present yourself well all the time. And this is why we we kind of hold you to these standards, even though it doesn't necessarily make sense from a technical perspective. I remember the hardest course I took as an undergrad was um, physics. And it wasn't because of the work itself. In fact, I love physics. I'm still a physics fanboy to this day. I loved the work. But the lab reports had to be perfect. They had to be typed. Again, that's another thing. Don't send me pictures of your chicken scratching on a piece of paper. Take the time. You've got tools. You've got word processors and stuff like that where you can write it out. Now, admittedly, I accepted your work, show your work on the conversions, but that's mathematics, and I recognize it's a very big pain to try to do mathematical symbols, a lot of mathematical symbols on a typed piece of paper. I wasn't really interested in that. But when you're presenting anything else, make sure you send it typed in on a file. Don't make me try to decipher your chicken scratchings and then you cross stuff out and add stuff at the end of sentences, and pretty soon it gets to be very, very hard. Let's face it, I'm not a young guy anymore. I can't, I need to have things pretty clear. So, that being said, I digressed a lot, but again, more background on what you need to think about in your algorithms. But again, let's look at the code. You notice the first part is pretty much the same as it was before. We're asking for the same integers. But notice here we get to the point where in the algorithm it said ask if the mean or median is to be calculated. And you see that what I did was I created a variable called calculation choice. Notice the big difference here. There's no int. That's because I'm going to take in a string. Instead of converting the string that is the normal default for input to an integer, I just accepted it as a string. So now calculation choice is as you can see right here where I'm hovering over it, it is a string. And that's because I'm going to do string comparisons as part of the conditionals. So again, add all three numbers together and label it S. So I say if calculation choice is, now this is another huge thing to remember, and this is something that causes people no end of problems, and you will make the mistake probably more than once. I did it too when I first started adding this in here. I just completely spaced it for about a minute and then I figured it out. Remember that the equal sign, if a single equal sign exists, that is what is known as the assignment operator. It says take the value on the right side, whatever that equation turns out to be, whatever the result of the equation on the right side is, and put it in the memory location known as whatever. That's what assignment is. Move something into a memory location. You don't know the actual memory location, but you gave it a name. So in this case, I've created there's a variable called S that will take the sum of the first, second, and third numbers. Okay. Same thing as before, but notice, getting back to this, that's the assignment operator right here. But when you have two equals is the actual equality symbol. And that's a Boolean operator, and I'm sure, and I remember Micah talks about this as well, but you're going to see this before Micah. But in this case, we're saying if the contents of the calculation choice variable, in other words, the what is in the memory location that is named calculation choice contains the literal letters MEAN, just MEAN, not the quotation marks, then it is true. The condition is true. If it has anything else other than those four characters, it is false. And so this becomes important as well, and I'm going to demonstrate it when we operate the program. This becomes very important because this also implies case sensitivity, which we'll get into shortly later, and then perhaps at some other point we'll talk about how we would get around some of that. So anyway, as before, we're going to add the first, second, and third number and add it to the variable called s. And so s will contain the sum of the three numbers, and then we're going to divide again using integer division. So the thing about integer division you got to remember is it's going to truncate the fractional part, so you only get the whole number part. And it's very, very important. I'm sure I remember stressing this the last time, and I'm going to continue to stress it. It's very, very important. If you've done your first program, you should already recognize that. But it's very important that you keep track of whether you want the whole number part or you want the remainder part or whether you're doing a decimal arithmetic. Very important. Again, in this case, I'm doing the integer arithmetic to get the whole number part. And then printing, notice that the other thing to notice is on the if, we got the colon afterwards that says this is the end of the conditional part of the statement. And if it is that, and that says what follows after is true, is if it's true. I will execute the following statements if it is true. And those statements are further, they are all indented. You'll notice that they're all indented. So all three of these, the S equals, the A equals, and the print will all execute if and only if calculation choice is equal to mean. Otherwise, they don't execute. Then down here we have the elif, which says that, well, okay, if that first thing, if calculation choice is not mean, what do we do then? Well, then I say if calculation choice is median. This is our second possibility, right? So, in that case, it just says print the mean of blah, 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 and then I just simply print out the second number. There's no other calculation to do, as I said before, in this limited example. Now, later on, we'll probably have to do some stuff in there that'll be different, but today, that's enough. Notice, though, that I also added an else. Else is kind of like, if all else fails, at the very end, if everything else above is true, every conditional above is true, if every conditional above is false, then we execute the else statement. This is your catch-all. If nothing else works, do this. And this is where I inserted a little bit of I wouldn't call it error correction, but at least error handling. It's a very gross error handling method. What you don't want to do is, one of the things you have to keep in mind when you're getting input is to validate the input of the user. Because if you don't validate the input, it's very possible that they could enter something in there that doesn't make sense. In this case, I asked for mean, whether they wanted mean or median, and if they entered in 5, the letter number 5, what am I supposed to do? Well, in reality, in this case, it would just come back and say invalid input. But if I didn't have this else in here, it would probably do nothing. And there would be nothing left. Actually, we'll play with that. We'll see what happens if we didn't have this else if. That's enough talking about it. Let's run it. Pretty straightforward. You're going to see. Oh shoot! You can't see for some reason the output window appeared on the other screen. So here you see the output window. So we're going to do our 10, 20, and 30. And notice it says now we get the prompt, mean or median. So we'll just, to make sure it still works, we'll do mean. Okay. And we got the good print. Okay, it did what it was supposed to do. Okay, so the mean works. Let's try median. And again, it puts it up on the other screen. Okay, let's do the same. 10, 20, 30. And this time we'll say we're going to do the median. And okay, 20. This is what you'd expect to be. It's the middle of the numbers, right? 10, 20, 30. So that's good. All right. Now let's see what happens. Again, we gotta probably move the stupid. Yeah, gotta move the stupid thing over. Okay. And let's do 10, 10, 20, 30. I want to do the mode this time. Oh, invalid input. Okay. All right. Just for grins, though, what would happen if... Now, this is one of the very helpful things about commenting characters. You sometimes just play with things without altering your code dramatically. You can just put a little thing in there and say, okay, we're not going to execute that. What happens now? And again, with the thing, okay, cool. And 10, 20, 30, median. Nothing happened. Now, as a user, you're like, why didn't I get a result? Well, you didn't get a result because you noticed that I used a capital letter M instead of the little n. And again, as I said before, that equals sign is going to say, it's going to go letter by letter, literal by literal. And so consequently, a big M is not the same as a little m. Remember I told you about ASCII codes a while back. They have two different ASCII codes. Otherwise, you wouldn't be able to use upper and lowercase at all. So you've got two different ASCII codes, and that's what it's doing. It's matching ASCII code by ASCII code. And if they're not the same, there wasn't anything to be done. And just to have this happen is, that would be extremely sloppy coding. It's, unprofessional. If someone does something wrong, you need to tell them something went wrong. If you can, you try to fix it. If you can't, you at least tell them that something went wrong and what was wrong. And so that's an important skill to remember. Anyway, that's about all there is. Again, I think you've got 2 videos from Micah to talk about conditionals, and where she'll go into greater depth about these things. And so I'll leave you with that. And again, look forward to like next week. I'm trying to remember next week whether we've got. I think we've got exams next week, if I remember rightly. Which means we'll have some review material out there and everything, so that you can take a look. You can prepare for you have some additional review material for the exam. I think it's next week. If it's not next week, it's the week after. But we've got exams coming up real quick, and that kind of puts a slowdown in our programming progress. But that's all we got for today. So, have a good one. We'll talk to you soon. Bye.